My name is Christian. I'm here with Hugo from MinIO. The booth is just at the side. And we're going to talk about research data extensions at the Max Planck Institute for Human Development. So a couple of slides, or a couple of words about myself, not slides. I started in a conservative automotive and hardware vendor environment, and when containers came around, and I think that's when MinIO also started, basically in 2014, I went to the cloud, I went to PlayStation Now, Docker, and AWS, and since 2022, I'm a freelancer and consultant. And last year, I joined a project with the Max Planck Institute for Human Development to do this project that we are going to talk about today. The Max Planck Society is kind of the umbrella organization above all the institutes, and it conducts basic research in natural science, life science, and humanities. It was founded in 1948, and it has 31 Nobel laureates in their ranks, 84 institutes and research organizations, or research institutes, one of which is said Max Planck Institute for Human Development. It's dedicated to human development, education development, and human-machine interaction studies. And the fun part about it is that it has a lot of interdisciplinary research, disciplines like psychology, education, medicine, history, computer science, math. You can find a lot of different disciplines in the Max Planck Institute for Human Development. And those, of course, do research, right? So the data challenge for the Max Planck Institute varies a lot. Most of the disciplines I just talked about, they maybe have smaller data like structured text, maybe some JSON or database dumps. But the majority of data that is produced and used is MRI scans. You see one MRI scan image here on the top right. An MRI scan is dozens of gigabytes per scan, up to 30 gigabytes. And the raw scan, of course, it's not really usable for a lot of science. You need to transform it, make averages over multiple scans, create videos, create data analytics out of it. So that's also like the 30 gigabytes is not the only data that's produced. You create a lot of derivative data from this MRI scans. That said, the data we expect to be rather cold, like compared to other research data, because once the scanning is done, the raw format is not really touched anymore. It's maybe read, but it's not really changed. And the derivatives as well. Like there are common derivatives that you create anyways, and once everything is created, they will sit in the data store and they will be read, but not written anymore. We have a 1 petabyte legacy storage, which is expensive and rather inflexible, and we'll get to that in the next slide, which is also very much utilized at 80% utilization. And the Max Planck the Institute is rather small with 500 employees, but it has a big pipeline of new MRI machines, even more than the Charité in Berlin, which I think is the internal competitor. But they have like a couple of machines in the pipeline, so the data generation will even grow in the next couple of months of years. The application stack is, of course, historically centered around MRI scans. As I said, transforming this into different formats, averaging the data, or creating videos or other derivatives from the MRI scans. But what sneaks up left and right, of course, is AI and ML. Not only for the MRI scans itself, like predicting or detecting diseases, but also for the human sciences or the human behavior studies, where you have like large language models to be trained, where maybe you work with ChatGPT and all the derivatives, and you try to replicate them or analyze them and find out what the actual biases are and how to counter them. So there's a lot of stuff going on in the AI/ML world there as well. Apart from that, heavy hitters, let's say, there are a lot of analytics scripts, MATLAB, Python, you name it, the script language, scientists will just use it, right? And apart from this interactive part of it, there's a lot of surveys and experiments, which are basically websites where you interact with inferences of large language models, or you interact, or you have pictures that you need to deal with. And those are maybe run on AWS or a Kubernetes cluster, virtual machines, On-Prem, it's a mixed bag. The architecture that comes from that is, of course, first, and I'm an HPC guy, so I like HPC clusters. It's a Linux HPC cluster in the basement with GPUs and local ephemeral scratch file system. What does it mean? It means that it's not backupped, it's not persistent over a couple of months. It's just like you download the data that you need on this, you compute it, you have access from multiple machines to it, and once it's done, you upload it to a persistent storage. The researchers, of course, have workstations, laptops, maybe with GPUs to run their own scripts, to run their own local training, to test some data out. And as I said, there's also AWS resources. If like new GPUs are needed, maybe for a short period of time for testing, they might use cloud resources. There are Kubernetes clusters, and there are a lot of different other Max Planck Society resources, like research clusters in other institutes or common infrastructure providers within the society that people can use. And of course, the traditional storage application, which is Dell Isilon, only exports Samba and CIFS, and with all the above, with all the different resources used, it's pretty hard to get the data from the storage to the different resources, right? So that's like the backstory, and we came up last year with the solution to like move to the next level of storage with MinIO, which is based on a rancher, like a virtual Kubernetes in an infrastructure provider for the society, where the Kubernetes cluster is virtualized and managed by the infrastructure provider. We just bought hardware, like off-the-shelf storage hardware with SSDs and HDDs, and shipped it to the co-location, which is in Göttingen, and integrated it into the Kubernetes cluster. And the integration was rather easy, right? You ship it, if it's available as a node and you have all the disks, you install the DirectPV CSI driver from MinIO, for MinIO, which deals with discovering the disks, formatting it, mounting it, scheduling and monitoring the disk, because otherwise Kubernetes would have like one persistent volume that you can mount maybe from a different location. To deal with all this jazz, you have this DirectPV CSI driver. And then you need the MinIO operator, which has a CRD, like a custom resource definition for Kubernetes to deal with clusters, with tenants, right? So the SDD nodes, they are one tenant with 112 terabyte of SSD or NVMe storage. And we have the HDD nodes, which have 1.4 petabytes of spinning disk as another tenant. And those two tenants, the SDD is the hot one and the HDD is a warm one, are combined for like the storage use. So users have access only to the SSD, or they only see the SSD tier, the hot tier. And once the data is not used anymore, or like for a day, you can define it with a lifecycle management. The data is physically moved to the HDD tier, even though it's still visible on the hot storage. And then once it's accessed again, it's transitioned back to the SSD tier, and then it's available on the fast storage. And of course, this is like a hot tier and warm tier configuration. We need archival as well, so we might have like a cold storage where we say like if it's not used for, I don't know, a month or so, we already put it to tape. Or if it's tagged in the life cycle as it will never change again, we might just put it on tape as well to be safe. All right, why do we use object storage? Research data in general has a very objective nature, like an object nature to us at least, right? So the MRI scans are done once, never changed, it's an object, right? So you have a life cycle that you can put on this. Also the derivatives, they are created once, and then you have a life cycle as well, they are never changed. We don't really have the need of a live update to certain data. Research data is also decoupled from other projects, so that you have maybe project 1 with a set of participants and project 2 with another set of participants, and those have different life cycles and different lengths, so they're pretty much decoupled. You of course have meta-analytic or meta projects that do like research on a lot of different projects, but for this you can provide them read-only access for a certain period of time as well. So that's pretty easy to deal with it. And all of that is of course kind of like research data management, which is very important to research in general, but Max Planck Institute as well. It will benefit from this because it's now that we have this structure of, okay, you have an object store, you have a bucket maybe per project, we can define and monitor the different life cycles and stages the data is in much more easier than we did it on the old legacy storage. So we can just say, okay, look at this event stream and we can deal with it pretty much. So the other thing that's really important to us and which was a struggle the last couple of years is with more and more macOS devices coming in, Samba and CIFS was rather brittle to access, right? Even worse with COVID and home office and VPNs, it doesn't help here, right? So if you have a Samba connection, CIFS connection from home over like a shoestring, then it really sucks. So by using S3 and HTTPS and software like clients like Mountain Duck, so if you have an S3 storage, look at Mountain Duck, it's pretty nice. It has kind of a Dropbox view to it, so you mount a bucket into your file system on Mac or Windows, doesn't matter. And it looks like the data is stored on your machine like it is, but you can just define with the right mouse click, you can say, store this all the time on my machine or just delete it here locally until I need it again. So it's pretty flexible and it's really nice. It makes it much more stable and robust to access data from home or from VPNs or on macOS devices. Another hassle for our users and researchers is once they want to share data with external project members, maybe they work with a hospital in, I don't know, Hamburg or Frankfurt or whatever, which is not a Max Planck Institute, it's hard to get the data to them, right? Because you don't have the login credentials to access the data and all this jazz. And what they did is they encrypted drives and sent them via UPS. Well, it kind of sucks, right? And with MinIO and object storage, we can just create a bucket to exchange data. We create an access key that's maybe only to drop data but not read it, so we can pretty much control how the data is accessed and read. And that makes it very easy for external projects and to access the data and share data between them. Another one, which is also very important, even though before it was not really possible, was to embed data into experiments. So if you say you have a website, you have a survey, and you want to include images or movies, of course you need to put it in the website itself. Now we can create a bucket with the public data of the website or the survey, and then a lot of frameworks for surveys, they can already read the data from the bucket, and it's pretty easy to set up a survey or an external website with big data, like big data in the sense of a file, into the survey. And similar to this is like S3 APIs are used left and right in different applications already, right? If you have PyTorch, TensorFlow, whatever, they can speak to S3 and have a bucket for the training data. You don't need to copy the data to your local machine. And a lot of other language models or libraries, they can speak to S3 pretty easily. And for instance, the new MRI machines, they can also put the data directly into the bucket. So we don't need to store it locally. We can just put in credentials in the machine that it just writes to a bucket and off we go, right? So we don't need to deal with the data shuffling that much. Why do we use MinIO? Of course, for an institute of the size of the Institute for Human Development, it's rather small, right? 500 employees or 600 maybe. And the central IT folks, they are a handful, and maybe 3 or 2 that will deal with this infrastructure. So we need the support contract where we can pick up the phone, call someone, maybe not strangling too much, but we need to have someone on the phone really quick, right? And for the MinIO contract, you have a push button, like an alarm button. If you freak out, then you press a button and you have someone on call. The panic button, yeah, the panic button. And you will have someone in touch pretty soon. And the other thing is we need to create the knowledge, right? Of course, traditional research environment, Kubernetes is something new, MinIO object store is something new, so we need to build the knowledge with the team, and why not have the training straight from the horse's mouth, right? So that's why having MinIO on board is pretty nice here as well. I already talked about the future-proofness of S3, and with MinIO we can hook into event streams, so we can see who is reading, who is writing. We can use this to maybe update profiles and see what happens in the cluster and monitor the heck out of it. That's pretty nice. Also, the ability, as I already alluded to assist research data management it's nifty here as well. We can define object life cycles. We can create profiles to have like meta-analytics or meta-analysis, just have access, read-only access to a lot of different buckets. So that's pretty cool. And another thing that I think all of you know is like this POSIX data dump attitude, that you have like a share for a group of researchers or a group in your company, and then they create directories in directories in directories, and you kind of lose track of all the nested directories in this. And with MinIO or with the object store, I think we can ensure that we don't have this anymore, because we have a strict policy that we have one project with one focus, has one bucket, and you are not allowed to have like a data dump bucket where you can put in all the things you want. So that's kind of the hope, at least. Let's see if we can pull this through. But yeah, that's also nice. The integration with existing identity providers worked out of the box. We have Azure or Entra ID now. That's like you integrate it and off you go. And now we can just scale out much easier, right? We don't have this vendor lock-in for the hardware. We just buy off-the-shelf hardware, off you go. Key features, like to sum up my part, and I'm already good in time, I think. S3 compatibility is, I think, the way for research computing to go anyways. You want to have this object store nature. It's rather simple to if you once you understood object store, and I use this for like 10 years or so maybe I'm overconfident, but I think it's simple. It's simple to integrate. The lifecycle management is awesome. I think will help research data management a lot. And application support for different libraries for training of AI ML models, it's going to be a blast as well. And as I said, we can scale this left and right, up and down, and I think it's going to be easier scalable, and we don't have this lock-in that we used to have. Okay, we will be at the MinIO booth afterwards, but first, Ugur, take it away.
Thanks, Christian. So, you guys have seen what Christian has been talking about and why we are popular with academics and research institutes, governments, and many other verticals in terms of across different industries. And the main reason that Christian mentioned are those two things. Before going into what we learned from large-scale deployments with MinIO, I want to emphasize two things that Christian mentioned. One is the hardware lock-in and appliance. Most of the industry is based on appliance and hardware lock-in type of solutions. And to get away from that, a lot of the customers that we have today are coming to MinIO. Software-only solution, S3 compatible APIs, and a full stack solution with all the features. That's one main reason. And the other reason that he mentioned is the protocol level. SMB and CIFS is a protocol going into the old school file system world with POSIX. In the new world, POSIX seems to be a hindrance. It becomes a blocker. It becomes at scale, it becomes so hard to manage, and it's brittle, as he mentioned, for many of the academic institutions, for research institutions, as well as in different commercial customers we have. I have 2-3 minutes just to summarize what Christian said in a MinIO perspective, and I just want to emphasize the value drivers that all of the customers that we have seen at MinIO today comes to us and says these are the things that we are solving for them. These are performance, cloud native, simplicity, and AI readiness. Simplicity is what Christian also mentioned. That's a common thread across all of the customers. MinIO, before we have put our UI in it, it was about 50 megabytes of a binary that was quite simple, one-liner for any developer to get started on a single instance. Of course, we go for large clusters and multiple instances for HA reasons and large enterprise deployments, but a single instance on a laptop can start in a single command line, and that translates into operational easiness of running it in a large enterprise. Performance, it scales linearly. We have benchmarking done at 32-node NVMe type of a cluster. We can get about 325 gigabytes with capital GB. We have one of the largest customer of ours is running 1.1 terabyte with a capital B throughput on a large cluster, more than 300 nodes or so, all NVMe. So that 300 number we get are from benchmarks to the customer experience of 1.1 is a linear scale, and as you add more nodes, you get more scale from MinIO performance. As a side effect of that good performance, encryption and other services that we have within our enterprise stack is so much less of an impact to the performance nature, because we have done the performance in a very nice way. We offload all of our erasure code and calculations to the chipset, and that's why the CPU cycles are easily available for the throughput of the application. Hence, we can reach those numbers from a performance perspective. Cloud native has always been in our DNA. From the early days of Docker, we have always been in that ecosystem, and we have always took to heart the orchestration, the microservices nature of it, cloud native way of building infrastructure. So we are all in for that kind of an ecosystem. So as a result of that, Kubernetes flavors of any kind uses MinIO as their object storage solution or their persistent storage solution in general as primary storage. And the last piece here is the AI readiness. The AI ecosystem is built on object storage from the get-go. If you look at the vector DBs, if you look at where you have your ML flows or AI flows sitting, all of their phases of data is all on object storage. And some of the vector databases like Milvus runs on MinIO from the get-go. So both from a flow perspective, AI ML flow perspective, also the modern data lake perspective, MinIO is at the core of it, and they started with object storage, and most of these tools are coming back to object storage and MinIO. As a result of all of this, we have built an enterprise-grade solution. This is a full-scale list of everything we have built for an enterprise. I'm not going to read on through all of these features. We can talk to you on our booth in detail, but S3 compatibility and erasure code and bitrot protection on the go is one of the key features that MinIO has built in, and that's one of the features that also Christian mentioned why they switched into a MinIO solution. And that's why we are very popular in the industry, because we have about 1.1 million downloads of Docker every day. And if we have some type of a bug or an issue within our code, we get it from the community, we get it from everybody complaining about that feature or an issue, and we fix it right away. And as a result, we have a hardened release of an enterprise-grade software that is available for our commercial customers. And in summary, before I open it up for questions and invite you to our booth for further discussion, we have built a highly adaptable horizontal system that can work across all industries. We have seen the example of a research institute and how they are making use of MinIO, but then we can be running on any cloud, any workload, and anywhere, and that's what we built the software for. AWS S3 is a great solution, but MinIO is the solution for everywhere else. If you're running on a colo, if you're running on-prem, or any other Kubernetes system, MinIO is your answer, and many of our customers come to MinIO for that reason. Economics is the other reason. You can get twice the performance, half the size of the hardware, and fraction of the FTEs, full-time employees that you have, and that's why one of the reasons why our customer come to MinIO and switch from the legacy technologies into a software-based solution. And I already mentioned about AI is built on top of object storage, and many of those tools, from Hugging Faces to Anthropic, we work with them in terms of how to use MinIO at the core of their system. So a lot of use cases in the new world of AI, and we can talk to you about those as well. Thanks for coming to our session, and I'm not going to take more time, but I will open up for a couple of minutes for questions for Christian and for myself, and we can continue our conversation at the booth, which is next door. Thank you.
While we wait for questions, I have one anecdote that just popped in my mind when you said like simplicity and this panic button thing. I accidentally, when I was developing Go code to like create profiles and create buckets with the live system, which is of course my fault, I guess, I overwrote the admin profile to be only read-only. That was kind of, like I almost clicked the panic button. Yeah. But of course it was like using the root credential, like I was able to recreate it. And what I should have done and what I did afterwards, of course, was creating like a MinIO Docker container on my laptop or in CI/CD. And of course, I should have thought about it beforehand. But of course, that makes it also easy, right? So you can spin up like testing environments, development environments, very, very easy. And that's,
It's absolutely straightforward. Go to the min.io website, download the binary, it's one line to get it started on your laptop. So I promise it's not more than one line. It's MinIO server and then the data mount point or the directory that you want to start this process in. You can get started less than 30 seconds.
All right, I guess we are almost on time, but maybe one question, maybe not. Then I guess the questions we could take at the booth. Thank you.